Hello and welcome friends. In this particular module, I wish to discuss about stationary container system of municipal solid waste collection. In this particular module, we will discuss the definition of the system, various features associated with the system, the definitions of basic terms that are associated with the stationary container system, and at the end we will discuss about the analyzing the system for the determination of vehicle requirement. Here, as you learn the content, you'll be able to explain basic features of stationary container system. You will also be able to define the basic terms associated with the system and analyze the system for defining vehicle requirement. We have been discussing about the functional elements of solid waste management. So already you know about how the waste is getting generated, where it is getting generated, how it is getting processed at the point of the generation, and its subsequent handling and the storage. As you know, these two things are associated with the particular site, whereas as the waste is now entering into the community bin, from that particular community bin it needs to be transported to various places according to the design of that solid waste management system. Say for example, transfer station, disposal station, or processing station. So this particular functional element onwards, how the waste can be collected, is being discussed under these types of collection systems. In the last presentation, we discussed about this hauled container system, and in this particular presentation, we'll be dealing with stationary container system. As far as the scope of this stationary container system for municipal solid waste collection is concerned, as depicted in the sketch, the container is expected to be remaining at the site where it is stored by the generator, or it could be a community bin. Its waste deposited content will only be picked up, it will be emptied down in the vehicle, and the container will be redeposited at that site only. As such, in this particular system, containers used for the storage of the waste remain at the point of waste generation except when moved for the collection. Hence, the term stationary. As you see here, picking up that particular container and emptying it in the body of that particular vehicle can be done either self-loading mechanism equipped with certain mechanical compactors. Also, one can employ the laborers in order to load that particular vehicle. Hence, there are two types of these particular stationary container systems. One is self-loading mechanical compactors. Second one is manually loaded vehicles. This particular labor requirement, as we discussed about the haul container system, is also valid for this particular stationary container system. If the waste collection is being done through this particular mechanical system, the crew could be just a driver and an assistant. Whereas, if the system expects the manual loading, it will be in need of 4 laborers, 5 laborers in addition to the driver of that particular vehicle. So, as far as operation is concerned, this particular system employs a vehicle with internal compaction mechanism, or it could be just open top or side loaded vehicle which may not have that compaction mechanism. As vehicle approaches the first collection site, the container will be picked up, it will be emptied into the vehicle. After emptying down the content, the vehicle will move to the next container location, and this particular process will be repeated till the vehicular capacity is exhausted. So as this particular vehicular capacity is exhausted, this point onward, it may move any of these particular destination points. Hence, this collection crew is responsible for driving the vehicle, in situ loading the content of these particular containers, hauling that particular containers to the destination point and emptying that particular content at that destination site. As the content are emptied at that particular destination site, vehicle will simply travel to the next container sites, and this particular process will be repeated. This particular system has got distinguished advantages. The first one is vehicle does not travel to the destination until it is full, giving its higher utilization. So the way we discussed, in haul container system, whether that particular container is full, partially filled, it was expected to be picked up. Here, it is not so. The vehicle will utilize its volumetric capacity fully. This kind of a system can be made applicable for variety of the waste. It could be residential establishment, it could be commercial sites. For this particular system, the container size and utilization are not as critical as they are in hauled container system, the way we discussed about the utilization of the volumetric capacity. Certain sites could be expecting delivery of bulky waste or white goods. So as we saw the collection mechanism, it could be mechanical jaw or it could be manual system. So if the waste is quite bulky, the system may not facilitate its collection. Also, if such contents are quite voluminous, picking up them in a single stretch may not be permissible as far as the volumetric capacity and collection mechanisms are concerned. The content that we discussed so far is summarized through this particular definition sketch. This is first container location. As the day starts, it could be daytime, it could be evening, it could be night. So the vehicle starts from the dispatch station and it comes to the first container location. The operation of picking up, emptying down will be taking place till the volumetric capacity of that particular vehicle is exhausted. After that, vehicle will be hauled to the destination point. The content will be emptied down and the vehicle will lead to the next collection trip. As the day hours allotted for collection are over, the vehicle will lead to the dispatch station. So, in line with this basic definition sketch, we can understand easily that this particular collection activity is associated with 4 different time slots. The first one is pickup, second one is hauling, third one is at site, and fourth one is off-road. As the vehicle approaches the first container location, at that moment the pickup time starts and it ends when the expected content of the various containers are fully loaded. Whereas, as the contents are fully loaded, vehicles will start its forward journey to the destination point and hence the hauling time will start. At site, it will spend the time towards the registration of the vehicle and emptying down the content and completing the formalities at that destination point. Whereas, after emptying down the content, the vehicle will lead to next collection trip and hence these 2 haulings in between the last container and the destination point and the destination point and the first container to be emptied for the second trip will constitute this haul time. You are already aware that as any collection system is being governed through the manual component, there will be in need of some lunchtime, health break, and such activities. Also, in addition, there could be traffic congestion, there could be unexpected arising repairs of the vehicle, there could be some unseen maintenance and associated time. So, in addition to pick up, haul, and add site, also there will be some allied time which is called as off-road time. So, checking in out congestions, equipment, health breaks, and such things would be necessary off-road timings, whereas unnecessarily dealing with some activities like speaking with the friends, unused time spending on the mobiles and such activities will be unnecessary off-road time. As we discussed on the previous slide, this time per trip can be expressed as TSCS, and it will be sum of pickup time per trip, at site time, and hauling time. This on-site time is typically observed for various sites, and accordingly it can be averaged out as 0.1 hour per trip. These haul times are function of speed of that particular vehicle as well as the distance of that particular destination point from the collection point and associated factors. This haul time can be expressed as A plus Bx, which is expressed as hours per trip. So depending on the speed of that particular vehicle, the A factor and B factor can be considered the way it is tabularized here. This pickup time per trip is given by CT times UC plus NP minus 1 dBc. So the way we discussed here, for a trip, as the vehicle approaches the first container location, pickup time starts. Hence, the number of containers located at the various locations and their corresponding unloading time will be taken into account by the first part of this particular expression as CT into UC. Whereas traveling in between these particular container locations would be given by NP minus 1 times dBc. Here, this NP is number of container locations per trip and dBc is the average time spent driving between the container locations. The number of containers which are emptied per trip can also be worked out by using this expression VR by CF. Here this V is the volume of the collection vehicle per trip, R is the compaction ratio which will be ranging in between 2 to 4, C is the average container value, and F indicates some empirical factor associated with its utilization. particular data studied, we can work out the number of trips that are required for a particular location. So this ND is nothing but the number of collection trips that are required per trip, which are given by VD by VR. Here this VD is nothing but average daily quantity of the waste to be collected, which is given as meter cube per day. V, the way we discussed here, it is nothing but the volume of collection vehicle, and R is the compaction ratio. Also, this time H allotted for that particular day can be expressed as T1 plus T2, where this particular T1 is the time which is required to reach the first container location, and T2 is the time which is required after covering the last location to go to the dispatch station from where the vehicle was started. This ND is nothing but number of collection trips. This TSCS is time per trip. W is the factor associated with off-road activities. Usually its value is taken as 0.50. For a particular case, if the data associated with the round trip distance and its corresponding speed is collected, we can work out the corresponding travel times. So having these particular basic data, we can work out the Hall constants A and B. So as you see here, in this particular graph, we have plotted this particular travel time versus the round trip distance. So as we get this particular data plotted, we'll be able to work out that particular y-intercept, which is nothing but the value of A, whereas we can work out the slope of that particular line, which will be nothing but the value of B. Hence, that H is equal to A plus Bx can be used in order to determine this round trip haul time. So for this particular data, it works out to be 0.52 hours. We can also determine the truck capacity. So the data associated with the various activities are given here. We also have to use these particular A and B factors for the given speed limit. So for this particular problem, the speed limit is given to be 88 kilometers per hour, and accordingly here A and B associated from this particular table we can consider. Various regions may be governing various speed limits, so associated with that we have to work out that A and B and can be used in order to determine the truck capacity for the collection. So here the first step is to determine the time available for each trip. We have this particular expression T1, T2, the number of trips, this W as the data given, we can substitute in order to work out the time available for each trip as 3.1 hours. Next part is determination of the pickup time. So we have the expression TSCS is equal to PSCS plus S plus H. So as we have the value of this particular TSCS, we can make use of it as we have worked out here 3.1 hour per trip, and the pickup time per trip can be worked out as 2.32 hours per trip. Here we wish to work out now the number of containers that can be emptied down per trip, which is CT. In this particular problem, it is mentioned that the average number of the containers per location are 2. Say, for example, if there are 3 locations, the number of containers that can be emptied per trip will be 6. Hence, this NP, which is number of container pickup locations per trip, can be expressed in terms of CT as we thought of this logic. NP would be 0.5 CT. So as we make use of the expression for the PSCS, the number of containers that can be emptied down per trip can be worked out as 16.13. So we'll consider this as 16, and we can make use of CT is equal to VR by CF in order to determine the truck capacity, which comes to be 19.2 cubic meter. So nearby available standard capacity such as 20 cubic meter can be adopted for the waste collection for that region if we are adopting stationary container system. For a given region, by making use of the same expressions, we can also determine the number of trips that are required or number of trucks that are required for that particular region. So we are assuming some data in order to work out this particular number of trucks. So by using this particular data, we wish to work out the number of locations one vehicle can serve in a day and number of vehicles that are required for some typical situation. Here again we are following the set of similar equations. Firstly, we have worked out that particular number of containers that can be emptied down per the trip as 58. Here, this NP will be equal to CT because average number of the container locations per trip is just 1. Hence, we can work out that particular PSCS as 6.71 hours. By making use of the same, we can determine the time available for the trip as 7.7 hours. And lastly, how many trips could be performed for a day can be worked out as 1.03, which is considered to be 1. So As we saw here, the number of containers that can be emptied down per trip is 58. Here, as we are performing just one trip, the number of locations one vehicle would serve would be 58 only. By making use of that particular 58, as we consider this particular 410 containers, the number of vehicles required can be worked out as 7.07. So, in order to have that particular 410 containers served for a day, this fraction can be neglected for the calculation purpose and to deal with the practical constraints by proposing slight increase in compaction so as to have the 7 vehicles. So I thank you for your attention. I hope the concepts that we discussed here are clear to you. In the next presentation, we will discuss about laying out collection routes. So bye till then. I wish you very happy learning. Thank you.